Well, hello everyone. So the topic that we are going to study today, it's called matrices. Now, matrices is a very important topic from the exam point of view because it's extremely easy to understand and learn its concepts. And after doing a set of basic problems or a fixed number of models, as I would call, as far as this topic is concerned, you'll be able to ace every question that comes in the examination. So that is the reason why you can't afford to lose grip on this topic. These are what I would say free marks in your examination. So let's move into understanding why we study matrices. So in fact, before we address the issue of what can be called as a matrix, what is a matrix, and what are the various operations done on matrices, we'll first move into understanding why do we study matrices. So to get this clear, or to set up context for this particular thing, what if I give you two numbers, 1 and 2, and if I ask you to add them, you'll easily tell me that the result is 3. That's fair enough. Let me give you a pair of two more numbers. So let's take 2 and 4. Let's take 7 and 8. You can easily say that the answers are 6 and 15, right? Now, if I give you this is just one particular operation here, like you're doing one set of 2 rows, as I would call. What if I give you 100 such rows, like two numbers in pairs and 100 of them to be added? Well, fine, it's not a lot to be done, but still it will take you some time to do this, and you can easily tell the result in the end, which would obviously have some scope of error. So keeping all that aside, it's still time taking, right? What if I give you 1,000,000 rows? If I give you 1,000,000 such rows, where you just have to add numbers and do no other operation, right? So addition is one of the most basic operations, and even in that, if I give you a 1,000,000 what do you say, a data of the order 1,000,000, it's extremely difficult for you to sit and calculate all of that one by one. So something similar goes on with the modern day computers. So for example, today's computers or today's modern form of technology uses something known as process. So this process is basically coded for you to put in data. It's coded for you to put in data, and the data will be passed through the process, and then you get the output in return, right? So instead of feeding the data one by one through the process and getting the result, what we do is we arrange all of this data. So what we do is we basically arrange this data in what is known as a matrix, and then make sure that the process accepts your input in the form of a matrix, which will have a lot of data, and then the output also will be in the form of a matrix, which will have the output data, right? So I could say that in a step, I was able to process a lot more data in a short amount of time, which I would if I were to feed data one by one and then get the result, right? So that is one way in which a matrix helps you, this sort of an arrangement. So matrix is nothing but a rectangular arrangement of data. So all of these data points can be put here in this sort of a rectangular arrangement, and then this arrangement altogether is passed through this process, and then the output is taken, right? So this is where your matrix actually helps you, and this is the reason why we study matrices. So having got a broad idea of why we study matrices, let's actually jump into understanding what a matrix is, how it's denoted, and then we'll follow on to understanding what are the various operations, the form of various operations that can be done on this form of data, which is known as matrix. So matrix is nothing but a data, right? It just has data which is arranged in a sequential manner in a rectangular format, but it is nothing in the end, it's nothing but data, right? So this data has to be processed and something has to be done with this data, right? So let's move into understanding what this particular arrangement is in detail.